Alright, so in this video, we're going to be solving the equation x to the power of x is equal to 8. So, at first glance, this problem may look challenging. So, to solve this, I'm going to first start by taking the ln, or natural log, on both sides. So I'll get ln x to the power of x is equal to ln 8. And a helpful property that comes with logarithms is that if I have something in the form ln a to the power of b, I can move this exponent to the front, so this turns into b times ln a. So in this case, I have ln x to the power of x, and I can move x to the front. So now I get x times ln x is equal to ln 8. Now from here, I'm going to use another formula that states that if I have something in the form w of a times e to the power of a, this is equal to a. And this is something known as the W-Lambert formula. So if I take the w of something in the form a times e to the power of a, it's going to equal a. So in this case, I'm going to rewrite this as ln x times e to the power of ln x is equal to ln 8, because x is the same thing as e to the power of ln x. So now I can use this formula. So I'm going to take the w on both sides. So I have w of ln x times e to the power of ln x is equal to, what I have to do on one side, I have to do the other side. So I w of ln 8. And this simply turns into e to the power of ln x is equal to, ln x is equal to w of ln 8. And then now I'm going to take e to the power of both sides. So I get e to the power of ln x is equal to e to the power of w of ln 8. And e and ln cancel out. So I get x is equal to e to the power of w of ln 8. So this is my value of x. If you haven't already, please make sure to subscribe, leave a like, and share this to any of your friends and family members. And I have a lot of problems like these on my channel, so please make sure to go ahead and check them out. Thank you guys for watching. Alright, so in this video, I'm going to be solving the equation 5 to the power of x is equal to 50. So to first start with this problem, let's test different values of x. So if x is 1, then I get 5 to the power of 1, which is equal to 5. And this is too low. Now if x equals 2, I get 5 to the power of 2, which is 25. And this again is too low. Now if x equals 3, then I have 5 to the power of 3, which is 125. And this is way too high. So we know that the value of x is going to be somewhere in between 2 and 3, meaning it's going to be a decimal. So how are we going to find the exact value of x? Well, to start, we're going to be using logarithms. So I'm going to take the log on both sides. So I get log 5 to the power of x is equal to log 50. And the reason I'm doing this is because logarithms come with a special property that state that if I have something in the form log a to the power of b, I can actually move the exponent b to the front, so this turns into b times log a. So in this case, I have log 5 to the power of x, and we can think of x as b, and I can move this x to the front, so now I get x times log 5 is equal to log 50. And now remember, we want to find the value of x, so all we have to do that is to get rid of this log 5 by dividing both sides by log 5. So now these two cancel out, and I get x is equal to log 50 over log 5. And now, let's simplify this a little to get the exact decimal value. So log 50 is the same thing as log of 10 times 5. And another property of logarithms is that if I have something in the form log of a times b, this is equal to log a plus log b. So now this turns into log 10 plus log 5 over log 5, which is the same thing as log 10 over log 5 plus log 5 over log 5, which is just 1. And log 10 is also equal to 1. So I get x equals 1 over log 5 plus 1. So now all that's left to do is do 1 divided by log 5 in my calculator. So I get x is equal to 1.431 plus 1, which is equal to 2.431. So this is my answer.